move to next two subchapter together. Within the chapter 1, working with numbers, we will discuss what are the labels, which we will use that to attach name to number. And then the 0103, we discuss the different kinds of numbers. So first, let's see this label. So label, as we start designing more complex Python program, will assign name to number. Name, actually, you can treat that as our name or normal way. So we call that as the variable. So that is the so that is not work here as well. But you can see here, Control L, actually is clear those one. So let's use this sample. So we put a equal to 3. So we cite equal, but actually this in programming is normally is not as the equal. So equal means we compare left to right. So that is equal means logical comparison. So there is a single equation sign. Normally you should describe that like we assign 3 to our variable a. Or now we call that simply is like a label. So we assign 3 our label. So here we cite is attaching the a to number 3. So then from now on, no matter is a label or formal name is a variable, now a is representing our number 3. So whenever we see use a for some operating a plus 1, then you get 4 because a will be replaced by our actual number 3. For here, if you cite is a powered by 2, then you get 9 because it's like you do the 3. And then you can change this assignment. Now I attach a to 5. Then I put is a plus 1. You don't need to have the space actually, so space is ignored. So this looks not nice, but it's not wrong. So now for this calculation, a is attached by 5. So you use 5 plus 1, then you get 6. So at first we assign number to 3, at second we assign number to 5, or change number. This kind of name is called a label. You may have been introduced to the term variable to describe same idea. However, considering that a variable is also a mathematical term, variable, so used to refer to something like x in the equation x plus 2 equal to 3. So in this book, only in this book is the author mentioned here is we use a variable only in the context of the mathematical equation and use a label here to see if you attach our label to a number. So that is our little more the description mentioned here. So hope is not give you any confusing. So actually, I think it's a little the strange is those part I cannot clear. So even if I clear the screen, so it's still in the bottom. So but let's leave that. Second part is we move to the third subchapter to show you the different kinds of number. So you may notice that we use two kinds of number to demonstrate the mathematical operation. One is the without a decimal point, which we already know that is called integer. With decimal point, normally we call that floating. So, but floating is just like the integer with another floating part. But before we go to the sample, actually let's show you some the nice picture summarize I got from website. So about the numbers definition and the range. So let's first have our the the picture in your mind. So the number in the high level, all we see from the fundamental. From let's imagine you back to primary school, the grade 1. First, you learn the natural number. Natural number is just 1, 2, 3, 4, all the positive and integer. And in some article, actually there's some argument is 0 is by some situation is treated as a natural number, some situation is not, but that is not a big issue. But with 0, actually we call that is the whole number. But whole number doesn't have, we normally call this whole number started as the positive whole number. Then if you have a negative number, actually we call those as an integer. Integer is also the whole number, but they have the 0, they have the positive, the whole number, and the negative whole number. And if you're starting to have those floating point and the number after floating point, you get the floating number, but actually you move to the rational number area. Those floating number actually is no difference to the fractions number, because if you actually do the division operating, 5 divided by 8, you will get 0.57 the 625. So that is the conversion between equivalent conversion between the floating number and the fraction. So and also compare on the contrary of the rational number, you have the irrational number. The irrational number is all the things is you don't have, you have first, this one is also a type of the rational number. This the short line above the number means this in the floating part is cycled by 42. So that is actually our infinity. Infinity, the length is actually is 0.424242 without our ending. So, but if you cannot find our cycle pattern, that will called our irrational number. And if you grand total rational and irrational, we call that a real number. And on the another side is we have our complex number. So in this number 3 subchapter, we will introduce fraction and also complex, so that you have more the complicated number classification and know how this will be used in Python. So I don't use IDLE, but you can use that as well. So this terminal you can use within the this VS Code can also provide the same the purpose. So first is let's talk about the type. So in every programming language, you got the data type. So in Python is you can put a type, and with parentheses you put a number inside. Then it will tell you the this type name. So it's our class, because Python is also treat the element as a class or class oriented. So this whole number is called the integer. And if I put is a assigned to by 3, then if I type a, it's same as I make is the type 3. So it's also integer. And if I put is a 3.5, it will tell you the float. And similarly is whenever they see are the floating point, no matter is after floating point is just a 0 or have some real the digit, is our float. So that is the integer and the float. Some of the program we write in the chapter will work properly only with the integer. So as we just saw, Python won't recognize a number like 1.0 or 4.0 as an integer. So if you want to accept the number like that as a valid input, you need to do the conversion. So conversion is you put the type before your number. So let's see. So I use int called integer 3.5. I convert that. It's convert to the floor, the number. Similarly, if I convert 4.0, it will get the 4. And I put is the float. I got is 3 is the whole number. They will tell you it's a 3.0. So that is the converting each other. So, and then the fraction. So let's go to this part. Python can also handle fraction. So they can show you the fraction in the the way with those the type of the name. But fraction is like this, 3 divided by 4. So it's just the 0.75. You can see you convert. But this is just our division operating. So it's not like our fraction number called the recorded. The fraction module is part of the standard library, meaning it's already installed. So we don't need to install any other modules, but you need to load that. So we use this from fractions import starting from capital F fraction. So once you import that, now you can use the fraction, the formula. So we call this F attached to the fraction 3, 4. So first 3 is above this fraction line, and 4 is in the below that. And then if you put here, so if you see F is described as the fraction. So that will be the clear is because we just try to store that as a fraction. So this create the fraction object of the fraction 3 3/4. When we print the object in 3, display this as the fraction. So the above the fraction line is the numerator. The below the fraction line is called is the numerator. So that is the way is better than you show that in 3 divided by 4. So now is I can use this directly. You can use fraction. Maybe I use the 5, 8. I don't use that I already have assigned to F. So that is 5, 8 is the 0.625. I use that to plus 1. So let's see. So it's tell you is also a fraction, but now is 1 is the 8 divided by 8. So the both this numerator and the denominator is 8. So in the numerator is 5 plus 8 is 13. So now it's another fraction. But if you use this like here, so if you plus that, you get our floating number. So it's not a fraction. So I can also use F plus 1. Then I got another fraction is 7, 4. So that is the way is Python will treat this as our data type. So type F is the class fraction dot fraction. So that is like is what we load. We load fractions class and load this object or the library and load the fraction class. So that is the way. So you can also make our fraction with fractions with this operator, like this fraction 3, 4 plus 1 and then plus fraction. Just ensure is the first F is in capital, is 1, 4. You go to fraction 2, 1. So fraction 1, 4. So let's see, fraction 1, 4 is also same as you use this comma. You use that write as this division is also the same as this as the 1/4, and the one here is the 3/4. So this plus this actually is 1. And here is another one, so you got 2. So 2 is the 2 is in this numerator, and below that is the 1. So that is a fraction to 1. So that is the fraction. And then let's go to the complex. So complex number is in the right part of the this number classification. It's kind of the more deeper level when you go to, I think it's go to the middle high school. You will starting to learn this. They have our a real part and this another part. We will call that is the imaginary part. So we use the J as the symbol to show those complex number. So if we define A assigned to 2 plus 3J, now let's see type A is tell you it's a complex number now because Python already recognized J. And the 2 is the real part, 3 is the imaginary part. So if I put this 4 equal to B equal to 3 plus 5J. So if I make it A plus B, so you go that is they have parentheses, but they add your real parts, and they also add your imaginary parts separately. So now you get 5 plus 8J. So that is the basic the plus or the addition, the operation for complex number. So we already demo until here and also demo this one. Similarly, is if you use A minus by B, so you get this the real part they do the minus, and imaginary part is also do the minus. So on both part. So and the multiplication and division are also carry out similarly. So if you now is I put it A times B. So A is actually is here is A is the minus 9. So and B the imaginary part is also like this part. So they do this crossing the calculation. So if you put those the different ways, so you will see these rules. So here is I have 2 3 and 3 3. So the imaginary parts actually you can see is 2 times 3 minus 3 times 3. So that you get minus 3. And here is 2 times 3 plus 3 times 3, you get 15. So that is the one. So to my case is I think is I have this one 2 5. Oh, this is looks like is I already have some change 8 times this one. The plus. So let's to use the 3 and A times B. So minus 3 plus 15J, and A times divided by B. So you got our very the long floating number. So I will not show you how to calculate that, but you just remember here first is the addition, this subtraction, multiply, division are all available for those complex number. Just they are not like the single real number. Is that you need to follow some way, some rules for the complex number calculation. And also the and the flow division are not valid for complex number because they are not actually like a real number. You cannot see what are their floor number looks like, and you are not divided by a single number. So this modular is no definition actually. And then the real part and the imaginary part of a complex number can be retrieved using its real and imagined IMAG, in short, attribute. So if I have RB, like its real part is 3, and that is, let's create something different. 10 plus 15. So I put its real part and the imaginary part is different. Then what I can do is if you want to retrieve this 10 from the real part, you get the b dot real. But be caution is what the result you get is our floating number. Similarly, is IMAG. So you got that is the imaginary part. Just try to remember these two, the method. So, but you don't need to quite remember those. Actually, you can refer back this book like our dictionary, or you can check from the Python's documentation. That is not our difficult thing. And then the conjugate of our complex number has the same real number but an imaginary part with an equal magnitude and an opposite side. So which means z, if I have this 2 plus 3j, the conjugate is the 2 minus. Just change this imaginary parts with the negative or the opposite sign. So I have this b here. So I will do this b dot conjugate. So I got this 10 minus 15. So then is if I put this c equal to b dot conjugate, then c is this 10 minus 15. So if you add the complex number with this complex number's conjugate number, then actually is you are clear the imaginary part. But this type b plus c, you can see it's still a complex number. It's not to remove your imaginary parts. It's still a complex. The only way is you can do that is to don't have our the imaginary part is through this real. So you get that is 20 without the imaginary parts. So in short is keep in mind what's the result, a type of the result for any of your operations. And then this we have another concept to introduce is you can calculate the magnitude of our complex number. So this magnitude is like it's a square root. Inside is the x, this power 2 with plus this y power with 2. So in Python, this would look like this way, because it looks like it's, we extract the real part, then extract the imaginary part, then this powered by the 1/3, this 1/2, so it's 0.5. So if my b is this one, so what I can do is b dot real. So you don't need our parentheses because b dot real is just our single number, so you can just use this power. Then z b dot imagine, then power, then power 0.5. Then I got this. I think it's I have the different the number, so I got this 18 point something. A simpler way for making this magnitude is there's our function called ABS, or you can see that is absolute. The function return the absolute value when called with a real number. And for the complex number, actually is return the magnitude. So if I see here is ABS, if I see the 5, they return 5. ABS minus 5, they return the minus 5. But those are for the real number. For the complex number, you can see they return the magnitude number. So those are the demos. I hope is you also in your either the IDLE or you use this terminal in VS Code. Both you have also successfully tried those operators. Those are another the review for your the existing knowledge. And then next video, we will starting to do some interaction with computer. So now it's just you input something and you immediately get a result, but the computer looks like it's just a wait and just like our calculator. But next one is let's talk about is how computer is getting user input. So see you in the next video.